Okay, I guess it's time. So, hi everyone, I'm Chris, Blue CMD on the internet, and I'm here to talk about greenfield project BMCs and why we should do them and what value they can add. So first, okay, that didn't work. Let's see. How do I? No, I can't select the next slide. Should I maybe do? Okay, there we go. So yeah, sorry. Is it better? Or yeah. Okay. Well, so you're gonna hear some pretty pie in the sky things. So I feel I should start out by saying this is just crazy talk from me. So yeah, there are. So what is a greenfield product, right? So greenfield product refers to the fact that we have, instead of having an existing building, we build or we renovate or something like that. We start on this beautiful green land where there is nothing and we don't have any prior work or there is no constraints that are imposed. So more or less, this is, you take the technical legacy you have and then you just ignore it. You don't consider things like migration plans or other things. You just look at an idea and then think, wouldn't it be great if this worked? So yeah, it allows you to look at an idea and consider it for its best merit, not things, oh, what would a customer say if they had to use it? More like, how could it actually work? So yeah, you don't have any repercussions. It might be faster to prototype depending on how the framework is. Maybe there is a very strict process you have to follow in order to get something in some existing product. So this might be faster to prototype using a greenfield. It might serve as a way to validate something that other folks thinks is just crazy, and yeah, you might get some data that proves that this is actually useful. So for BMCs. Oh yeah, I should mention also there is one product that is doing some quite nice greenfield work that we have heard of already, which is Linux boot. They for example, they are looking at you don't have to use TFTP to boot from network, right? You can use HTTPS and stuff like that. And I think yeah, so there are some really interesting ideas there. So for BMCs though, which we're in this track looking at, what can we possibly want to change there? Well, so we have heard, for example, that maybe our trust model is not as good as it should be. We've been hearing a lot of this host BMC trust that has served us well in the past, but maybe not so much today. Where the provisioning story is also quite interesting, which we're gonna look a bit on as well. Authentication is another one where I think there is a lot of room for improvement that we can, and yeah, some ideas I'm going to present there as well. Then I have authorization, we have metrics, we have management, and we have, yes, there is quite a lot of things we can look at, but sadly we only have 30 minutes, so we're going to pick 3 of these, and these are going to be the 3 first that I mentioned. So what do I mean when I say revisiting the trust model? Well, so historically, the BMC has just been an assistant to the host, right? So whoever owns the host, like financial or otherwise, is the owner of the BMC. So why should you ever want to protect yourself from the host? Well, today that has changed, right? And you've seen that with the pants down vulnerability, where I am. So my thinking there is that was not a surprise for a lot of people working in the BMC space, because that is just how BMCs used to work. This became the CVE because our expectations from the customers has changed, not because something suddenly broke, right? So this is just how the industry has evolved, and we need to follow with the industry. So usually how do we do this? Well, we can just disconnect a lot of things from the host. That's simple as that, right? If you don't need like a PCI Express connection to the host, for example, for VGA or otherwise, you can just maybe buy a BMC that does not have that, or maybe disable the clock if you're already stuck with that BMC. So that can serve for a lot of the use cases to isolate that trust. But there is one concept that I would like to focus on that is a bit more tricky, that I don't think has received so much attention, but is still quite crucial, and that is, how do we acquire the wall clock time of the BMC? So today, how do we do this? Is we essentially, why should we care even about time? Well, a very obvious choice is logging, right? And anyone that has ever debugged something from two machines that have a clock skew or even the wrong time zone configured knows how painful that is. So, but yeah, and then you have things like scheduling, where maybe there is someone that does some kind of BMC API calls every X, and it's, you told the BMC to do it internally, and then you want to do that. I don't know. But the most important thing is authentication. So while maybe in the past this hasn't been a big problem, where we've been using password authentication and such, with times progressing, we are now looking into more advanced forms of authentication with certificates and time-based. So if when you have such authentication or credentials, if you control time, you control the life cycle, right? You can jump backwards in time, and then suddenly that credential that you managed to lift from someone is valid again. So this is quite important. Yes. So how do we acquire time today? A lot of systems just blindly copy it from the host, and that's the trust problem we have. So what can we use instead? Well, the first naive idea is to use NTP, and that works for a lot of cases. And it's for people not familiar with it, you just have public time servers out on the internet that you can just get your time from. The problem with this is that it's not secured and it's not authenticated. So if you're a bad actor and you're able to influence this, then you can lie. So there are some additions to NTP where you have secure NTP, but the problem with this is that doesn't really scale, and it hasn't been adopted publicly. So we need something else. There is this protocol called rough time, and the name kind of implies that you get a rough time. So it is a service meant to solve this problem, where you are not trusting the network, but you still need to know what the time is. So you have public servers operated by, for example, Google and Cloudflare that you can use for this. Simple introduction to rough time is that you generate a number. Doesn't have to mean anything for you. You give it to a rough time server, and you receive back a signed timestamp, radius, which we will talk about in a bit, and the signature. So you can validate that this was actually from this server. This is not encrypted, so anyone that is listening on this can also audit this. So it is possible to detect, for example, state-level attacks, where if a rough time server were to be compromised and only lie to certain IPs, that would be easily detectable for anyone that wishes. So what is, thanks to Cloudflare for these diagrams. So what is this radius? Well, the problem is that we're doing signatures and checking on potentially a lot of incoming requests. So what rough time does is that it has this concept of a batch, where the server can, in order to save CPU cycles or otherwise, batch everything together. So they say, okay, well, I'm going to wait for, an extreme example would be 5 seconds, and then take all the requests and then sign everything in one go. And there is a way for that to be done very efficiently in the protocol. And in that case, the radius would be 5 seconds, because you have an uncertainty of 5 seconds in that reply. So the problem here is, okay, well, we now have unauthenticated. or so we have an authenticated time window, but that is not good enough for logs. But we can use it together with NTP to get a precision or a precision timestamp. Sorry. This allows us to both have the PI needed, in that we have a time window where we can trust that the time is in, and we have the precision for logs. So the worst case scenario is that someone lies on the NTP, but that can just skew the time a bit, right? So your logs will maybe not be as precise, but I don't know, why would anyone, like as an attacker, why would you do that? There is nothing for you to gain. And more in pseudocode, not so much pseudocode, maybe it is part of a open source project where called UBMC, where this is more or less lifted from UBMC. Anyone familiar with Go knows that there are a couple of if error equals or not equals nil missing, but that's about it. So this is how simple it can be in order to get an authenticated time. Yeah, sorry, yeah.
So in the model,
in the model where the BMC is hardware root trust and it authenticates BIOS.
Yeah.
And if we expose an API to set time only in the BIOS, why do you think it's a challenge?
Why do you trust the BIOS here, right? If I'm on a bare metal, if I bought a server and I set the hardware clock to 1970, wouldn't the BMC trust that time in that case?
But how you can tamper with BIOS, because you're trusting BIOS, right? You're authenticating BIOS. That was the BIOS that you programmed during factory.
Time is stored in the hardware clock of the machine, right? So if I can just set the hardware clock, which is a normal thing for the operating system to do. So unless you have like two RTCs on the board where one is authenticated in some way and one is unauthenticated, which is the one you can, like, because as a customer, I would maybe want to be able to set my time. For example, a common thing that you have to choose is if you want the hardware clock to be UTC or local time. And if I'm installing an operating system on the bare metal that requires UTC or local time, and this BIOS clock is something else, I'm happy to talk about it afterwards, about this. Yeah, cool, thanks. So the trade-off that we're doing here is, of course, we're adding trust to some other servers, and we need a way to validate that. And in the case of rough time, we add some public keys for these servers. This is not very different from the trust store that BMCs already have in order to be able to validate HTTPS certificates. So it shouldn't be a big deal, but it's worth mentioning. So what we have gained here is that we have decoupled the trust of the host's time system, but we added a dependency on an independent third party. For some companies, this might be a problem, but there is really not such a big deal to run your own in-house runtime and compile your firmware or set your BMC to use your in-house runtime server instead. Okay, so we managed to look at that. And then we have two more pie in the sky things to look at. So provisioning. So this is, there is a slight typo here where this is normally how you would, you buy a box, you set up your own network, preferably not using the same IP that you're about to SSH into, but that's, your mileage may vary, I guess. So you set up your local IP address, and then you SSH to the machine you set up. You configure an IP, you change the password, you set a host name. Yeah, that's usually how you have to provision these. Incidentally, it's also interesting that California passed, I think it was a law 1 year ago or something, that forbids connected devices to have a default password. So how you SSH into the machine initially is also an interesting food for thought. But maybe if you're a bit more, a bigger corp, you have a process in order to register a MAC address for your global DHCP server that you then connect your server into that you can now straight SSH into the DNS name. That's a better way. You'd still have to set password. If you're lucky, the BMC accepted that hostname, but DHCP is an untrusted, unverified source. So that means that some actor on your network can change your hostname, which probably isn't a great thing. Another big thing, or a big problem with this approach, is when can anyone think of a problem with relying on DHCP like this? So when you have like either Raptors or a power outage in your data center and all your servers go down and then suddenly come back up, you have 10,000 servers that suddenly want the DHCP, if the DHCP server is even alive, because everything went down. So preferably, what we need is, instead of using DHCP, we need a magical protocol that supports automatic predictable addressing without collision, that is stateless, or at least not fan-in, and that is already supported. Preferably, it should also end with the number 6. But yeah, it turns out that IPv6 is everything we need here, because the router, instead of us asking for an IP address, the router is just constantly broadcasting, this is how network addresses looks like in this network. So the only thing you need to do is listen. If you don't have a router, maybe that went down in that power outage as well, you have the FE80 or the link local addresses. So relying on that is not a big deal. You can also use this broadcast add-on called RDNSS in order to add name servers. So you have a more or less perfect replacement for DHCP here. And it's all stateless. Almost. Because the one thing we're missing here is a host name. Right? So, and this is trickier, because host names it's kind of like Tolkien versus Smurfs. Right? So one company wants to name it X, some other one wants to name it A1. Right? So I don't think we will ever fix this or change this. So we need to accept that this is customer dependent and needs to come externally. But one way we can improve on this is we use something that is not, so DHCP is kind of an annoying protocol in that the DHCP server has to do a lot of things. It needs to maintain this lease database and calculate a bunch of things. So that is part of why it's so hard to scale that. DNS servers are really easy to scale in that you just have a static file mostly, and that you serve from a lot of these DNS servers. So if we use DNS instead, which is a part of DNS called pointers, reverse lookups. So instead of doing a hostname to IP, you do an IP to hostname. And this used in a lot of cases on the internet already. So essentially what we are looking at is that you do an IPv6 RA, so you listen into that when you boot up. And when you then have your IPv6 address, you do a reverse lookup on that and say, hey, what hostname is this? Oh, sorry. And that's how you get your hostname. So instead of doing a stateful handshake using DHCP, we now replace it by only doing stateless stuff. So in summary, what have we gained here? Well, we removed the need for having a DHCP server. You got a dependency on a DNS server. Most likely you already have that. You might not have configured it always. It might have been a best case thing. But yeah, now you actually need it, which might be a good thing or a bad thing, depending on how you look at it. There are data centers out there, quite big ones as well, that do not support IPv4 at all. Right? So now we have removed that problem. We replaced it with IPv6. Okay, let's do authentication. It's a broad topic. And oh, I only have 10 minutes left. Crap. Oh well. So let's only look at the server authentication. So how does that look today? Well, I found a picture that perfectly illustrates how server authentication is done today for embedded devices. And it looks like this, where you don't really have any trust at all on the device, right? So the first initial request that you do for any device that I know of does not contain a certificate that you have any idea to validate. So what some do is that they accept this warning, log in, and then replace the cert. And a lot of manuals say that you have to be using a trusted network. So you have to take the machine and connect it straight to your laptop, set everything up, and then replace the cert and all that stuff. That's pretty annoying. So, and not only that, actually. So the problem here is that we don't trust the BMC, but also nothing else trusts the BMC. So the BMC in this case cannot use its certificate in order to call any other kind of services. So what you can do is you can type danger. They changed that in Chrome, and we'll get back to that later. And then you get past this, or you can press all the buttons and you just say, yes, I accept all this risk. The problem is that people started printing this into manuals that, you go to this IP address of your thing, and then you type danger on your keyboard, and then you log in. Right? So they decided to change this, and I think they rotate this every other year or so now. It used to be bad idea, and then, something like that. This is insecure or something like that. So there must be a better way. This is not a problem on the internet. Why is it a problem on the BMCs? Well, I'm here to tell you there is a better way. So let's see. In the past, so okay, so let's look at it this way. What do we need? Well, the reason we see this is because the browser does not trust whoever created the certificate. In this case, it is ourselves. So there is a loop we have to break there. So what you usually do is you go to a certificate a certificate authority and buy a cert. This is how you've done it in the past, and they cost maybe $100 or so. We don't want everyone to have to buy a cert in order to log into their BMCs, of course. That's why it's so great that there is this service called Let's Encrypt. Let's Encrypt offers anyone trusted certificates, and they have an API to easily get this. They are a provider, or they are an implementer, I should say, of the Acme protocol. So if you don't want to use their CA, you can implement the Acme protocol, and they have plenty of service to do that inside your own company. So if you have like a corp CA that everyone trusts, you can use that for this instead. But for everyone else, we can use Let's Encrypt. But what do we need to do in order to use that? I'm sorry, I don't see the same slides as I'm seeing here. Oh, there we go. So the first challenge that Let's Encrypt requires you to respond to in order to prove that you should get a certificate is that you run a web server on a certain domain. That means putting our BMC on the internet, which probably is not a great idea. So let's not consider that at this time. The other thing they support is a DNS name we control. Well, lucky that we actually already solved this, that we now have a IPv6 address that always maps to our DNS name. So by doing this and trusting this, we can just add a single DNS delegation and say that the BMC is actually authoritative for that name. And there are plenty of ways to do this securely in modern DNS servers. So that's not a problem. So essentially what we're looking at is the first initial boot would be that the BMC does an Acme request to some provider. It has, like, maybe Let's Encrypt as a default. This provider does a DNS probe to validate that the BMC is still, or is the one it claims to be, and then in the Acme response you get a perfectly valid TLS certificate. This has the trust model here is that your network is secure, but that is already the case today. So that is not that is not a regression. And there are ways to solve this without trusting the networks as well, but this is the easiest way. So what have we done here? Well, we have replaced that manual and maybe not so used certificate management process. Maybe the big actors actually use to replace the self-signed certificate, but I have not seen a server that is not running UBMC that has a proper certificate. And we added a trusted machine identity, not only for us to trust that, but also now that machine is able to claim that it really is that machine to talk to any other service you might have in your network. So if you, for example, want to do SSL terminated syslogging, you can do that now. So instead of anyone being able to say, yes, I'm totally that mail server, you can now trust that from the BMC that this is actually the BMC that is logging. So in summary, we have a summary of the summary where our trusted time source enables us to do modern things like certificate authentication. By applying IPv6 and DNS machine provisioning, we are now compatible with the conventional web trust model, where we can use all the technologies and security benefits that provides, or that has been invented for the public web. I think that not secure, having that symbol is not cool, and we can do better. So in UBMC, which is a greenfield BMC built in Go using the same code base as Linux boot, this has been implemented. We focus on being very opinionated, as you probably saw, but that provides us with a very slim code base and offers us to really do crazy things and see how that turns out, and if we can move that forward. So if you enjoyed this or you want to keep in touch, this is how you keep up to date with what I'm doing, and this is where you go to check out the code for UBMC. And with this, I'm happy to take any questions. Yes. Yeah. I let it to Benjamin to bring the mic around. There was one here as well.
Thanks for the talk, Chris.
Thanks.
I've played with UBMC a bit. It's pretty cool. I'd like to get some of your ideas into OpenBMC. Do you have any plans?
Yeah, I've been chatting. I forgot with whom I chatted with, but we have a plan to write up this ACME proposal for OpenBMC, for example, how in OpenBMC I would see that as an optional way of setting up your provisioning, maybe doing some DHCP options to point out an ACME server. This is where you get your initial certificate. I think there is a lot of things we can play with there, and it would be really cool to do. That's like OpenBMC is like a good thing with OpenBMC is that it listens to a lot of people, and there is this whole process around contributing. But so there is more. It requires more time from my part in order to produce all the design documents and all that stuff. So I'm here to spark interest in the ideas. But yes, that is, for example, ACME is certainly something I would like to see how we can use in OpenBMC. IPv6 is also something I've been from the sides pushing more on. That when I started looking at OpenBMC, I think it was just getting IPv6 official support, but I really hope that we can make sure that everything is just working IPv6 only as well. So that is something that I'm quite excited about. But thanks.
My question is how the BMC, when the BMC is making a request to the ACME server, how is it secure?
So what you do when it is using HTTPS, and the HTTPS certificate store is usually shipped with a system. So does that answer your question, or do you want more details? Or
when we say like the BMC is always like shipping up with a self-signed certificates. So when the very first time when we ship the system, it's the self-signed certificates.
So in UBMC we don't have self-signed certificates. It does. It does not. Like the only certificate that is used is this Let's Encrypt provider one. So it never has a self-signed.
What I thought of like Let's Encrypt certificate, like you send a ECMI request and then you get a certificate.
Yes, exactly. But
so in that case, like very first time, how do you get a certificate?
But that is how you do it. Let's Encrypt. So when you think about it, when you go to like a normal web page using your browser, you don't need a certificate in order for that to be encrypted, right? The server has the certificate, so you don't need anything. And likewise, when UBMC does the initial request, it does not need anything. The way it authenticates to the server is by doing this DNS challenge that we saw, the pointer dance.
Does that mean like the client has to accept the server certificate whatsoever it is?
No, you can do that. That's a horrible way of doing it, but you can do it. But usually what you do is you ship this trust store of it. It has things like the name escapes me, but it has like VeriSign, super duper root CA that then has another CA, then has another CA, and then that's Let's Encrypt, right? So this is like a store. I think it's like Mozilla CA store or something like that contains hundreds of certificates that are globally trusted. This is how the HTTPS Web of Trust works. So you ship that with the BMC as well, and that allows it to do conventional HTTPS.
Oh, so you're saying like all the third-party signed certificates, the known root CA certificates would be there on the
Yeah.
Okay.
If you don't trust that for your company, maybe you want to run your own Acme server, things like that, then of course compile in whatever certs you want.
That's it.
Thanks.
I think so. I believe NTP has. I mean, like normally by default, if the drift is too large, it'll panic.
Yeah.
But there is a configuration where you can tinker it and say, "Don't panic on this one," so it'll accept
Right.
the drift.
So the problem with that is when UBMC starts, it does not require a RTC. Like in some cases, the BMCs do not have an RTC at all. So every time you boot, it's 9070. That's a very large drift that you need to accept there. So you can't sanity check, right? Like you have to accept whatever NTP reply you get. The alternative there is that you have an RTC for the BMC, but then you have to kind of trust the clock that came from factory, and then you just move the thing elsewhere. I've been messing a bit with, so on these BMC, for example, on the A speed, the initial power on from cold boot is 1970. But I use the A-Speed built-in RTC to keep the time across reboots at least. So you don't have to, like, you have slightly faster boot time the second time, because you still do the time dance, but you don't block boot on this. So in UBMC example, for example, everything's blocked on that first. You get the DNS name, and then you get the time, and then you get the certificate. This takes like 10 seconds, the first boot, but then the second boot, we still do that, but we do it in the background because we can operate on the previous results, if that makes sense. Well, did I answer your question?
Yeah.
Thanks.
Okay, thank you for your talking. You mentioned that you need to set up an in-house runtime server, right?
Yep.
It is trusted.
Sorry.
Then my question is, why not set up a trusted NTP server in-house?
You could do that. The NTP has a scalability issue. I didn't read into too much, because not having it publicly deployed was a blocker for me. But yes, you can certainly do a secure NTP. The problem with that is, of course, then you have one way of doing it for the businesses, and then one way of doing it for everyone that just wants like a like imagine that you're a business that want to deploy a server out at a customer. Maybe you're selling an appliance. Then maybe you can't use your secure NTP thing, because then you need to reach it over the internet, and maybe maybe it works. I don't know, but yeah, it's essentially to narrow down and create one solution that works for everyone.
Okay.
In regards to the NTP setup, do you have something to recheck rough time periodically to make sure you're not susceptible to skew attacks? And then the other question was, in the case of having many BMCs on a single layer 2, do you have a solution for making sure they can trust each other if they want to talk to each other, or they can't impersonate each other? Because right now with the Acme protocol, you couldn't actually guarantee that.
Right. So the Acme protocol doesn't, I mean, the Acme protocol relies on that the DNS works, right? Which I think is what you're getting at.
Well, no, I'm also getting at like you could NAC duplicate address detection request from another BMC and take their address and then run Acme on yourself and impersonate that BMC.
Yes, you trust
So
the
is there like
network,
some trust on first use model where you can have keys that are kind of persistent over the lifetime of the BMC,
So
that you know that that BMC is the same BMC and not a new one that showed up and took the address?
You can do that.
I'm just wondering if you have anything that you're like planning in that area.
So I've been thinking about this, but it mostly boils down to that it's a lot of work and there's a lot of things to fix before that. And a lot of people's threat model does not include the local network. So while we could certainly fix it, it feels more like a academic approach to security than something that someone would actually want to use. But if there is like a big user that wants, or someone that really wants to do this and would be happy to experiment, I'm happy to take any pull requests, or I don't know, just fork BMC and do whatever you want with it. Like I'm really interested to see what people think about this. I have some ideas, but it is quite like, networks in general, like there is, for example, 8021X, right, where you use a certificate in order to authenticate, and there is like things you can do there. You could also,
as long as your switch is supported that. If you were trying to talk from BMC to BMC, if you went out, you could just do it on the router. But
sure. But I'm happy to, if I have any ideas, I'm happy to talk to you about it.
So how do you realize this concept on an aggregated resource model where you have a rack and you have 48 blades in the rack, and then you have a rack manager, or sort of a manager for the rack, and then you have a consolidated kind of manager for the racks, and then, so basically where like a data center is sort of aggregated with respect to resources, right? So running a trusted time server might not scale, right? So when we already have a rack manager that is trusted, I mean, why do you think that all blades requesting DSCP at the same time might be an issue? And at the same time, why can't the blades trust the rack managers?
I mean, you can certainly create these elaborate chains if you want to. Roughtime doesn't require that. Right? It is made to scale to run publicly on the internet. And I'm pretty sure your data center is not going to be as big as the public internet. So, like, I mean, you can certainly, if you dimension it so that every server reboots at the same time and requires a Roughtime check at that time, Roughtime got you covered there. Like that's why it was created, to be able to scale to these things. Then your other part of that question was the chain of trust. And sure, like if you want to have that chain of trust, if it makes sense for your deployment, then go ahead. It's a lot of people don't have a rack management unit. A lot of companies run only a single machine or a handful of machines and run some VMware ESXi cluster over that, and that's the whole data center. So you shouldn't forget the small guys as well. But thanks for your question.
You suggested that
Sorry, I don't think the mic is just for the recording.
So you suggested that we don't need a DSCP for IPv6. So how do we get the first address? Like, do we assign it statically?
No. So in IPv6, the router always advertises
the RAs.
Yeah, the RAs, exactly. So the RAs use what's called SLAAAC, right? So we only use that. Like, you can use DHCP as well in order to get, if an enterprise or someone wants a more machine determined IP, you can use that. But in order to support everyone's use case where you don't have any other external infrastructure, you could use RAs.
Yeah, but at the same time, considering, as you said, the power down and 100 servers are
but the RA is not fan-in. It's one broadcast to everyone, right? Then you have the neighborhood discovery. So if you have like a enormous L2 domain, then you have some problems there. But that is not that doesn't change the power on story, because those neighborhood discoveries are sent periodically anyway. So that's already the status quo. So if the RA solution just works. Like DHCP, the way you normally configure this, I guess, is you would have like a DHCP relay set up. So all the different L2s that you have in your network would fan into the same DHCP server anyway. And usually that would receive very little traffic.
Mm-hmm.
So that's why you have this meltdown scenario. But in the RA case, if you segregate it, then all your routers or even if it's a single router, that RA would go out on every single L2, but the neighborhood discovery protocol would only run into that domain, right? So there would be no catastrophic meltdown as such.
Okay, thank you.
Yeah.
Well, no one else for neighbors doesn't care about anything, right? So, like, you're not going to ask for every neighbor. That's not a thing that you.
Oh, okay. I might be.
You're just going to ask for what you care about, what you're trying to talk to, which is probably the ground.
Right. Yeah, but I'm thinking if someone does like an FFOs2 : 1 thing, it's like, hey, give me.
In IPv6, they actually broadcast that to a multicast group,
right?
And so it only goes to the address based on like the suffix,
right?
And so it actually won't hit every node.
Oh,
the switches will actually filter it out.
But in this case, those multicast groups would be everyone in that L2, right?
No, it's based on like the suffix of the address. So if there's sufficient randomness, it'll only hit a small subset of nodes.
Oh, okay. I did not know that, but yeah, that's even better. Like it's
pretty scalable. It's pretty good.
Yep.
Don't you still have a thundering word problem if everyone comes up and asks for their host name?
Could you repeat it for the recording? Sorry.
Don't you still have a thundering horde problem if every node boots and then asks for its host name from the DNS?
Yeah, yes, but the problem with this is, or my assertion, or whatever the word is that DNS scales much better than DHCP. That DNS is just reading it from a static file, that you have all these DNS records and you can easily scale that statelessly.
But you wouldn't have a DNS record for a machine you had never heard of.
You would.
Right.
So the idea, the whole idea here is that you take the MAC address that you still need to do you need to assign your machine identity, your serial number, MAC address, whatever, with a host name that makes sense for your company. You're doing that in your DHCP today. You would do this here as well. So you would, in that process, you would assign that DNS record, right? So when you get like the bill from Lenovo or whoever you bought your server from, and you ask, okay, give me the MAC addresses of these servers so I can register them in our inventory system. You have them.
I don't know anyone who pre-registers MAC addresses.
We do it
unless you're in a huge data center.
So how would you associate the name of the machine in that case?
Mostly I don't bother with names for BMCs.
Right, but for the actual host, like how do you set like static IP everywhere?
Yeah, well.
How do you discover it for the first time?
You usually set a host name after you install it,
right?
And then the host registers with DHCP that host name,
right?
So you're setting the host name locally on the box.
On the host, yeah.
Right. So
which again, you won't bother with a BMC because
I mean, you can certainly do that. I think it's quite common in like Windows Active Directory setups that you do that. They have like this dynamic DNS setup. I'm not familiar with. To me, that sounds kind of scary. That every machine potentially has a way to manipulate the DNS and claim to be anyone. So in this scheme, but you're correct in that it requires a pre-processing step where you register the MAC address with the identity that you want that to have. But that is only assuming trust in the local network. That is the only step you have to do in this scenario. Yeah, but thanks for your question. I think we're.
Sorry, a question. So you trust the MAC address very much. So what happens if somebody overwrites the MAC address?
Right. But so that goes back to that the threat model is that the local network is trusted. Like there are ways we can change that, and it's just I don't think today the processes still require you to trust the network. Like we've seen so many things about the BMC where you have the self-signed certificate, right? You accept that. If you haven't uploaded another certificate there, you still trust the network, right? So there are data centers, I'm sure, where they are still running the default self-generated certificate on the BMC. So then in that case, it doesn't matter. Like, you're already susceptible to man-in-the-middle attacks because you're accepting whatever you're getting back from the BMC. So the MAC address doesn't really matter in that case, is my claim. You don't look like you agree, but...
Sorry, I just mean that the network I do trust, but I do not trust the machine itself.
Right.
So
well,
and
the machine is on the
itself
network,
changing
so
a bit.
yeah.
But you don't have any check right now that you would check the switch is connected to the right machine.
Right. But
So
I mean, so yes, like the threat model definitely makes this, like this is certainly something we can look into more, but it's it becomes really tricky because then you're entering the dimension of deployment specific things, right? You could add a MAC filter on the port of the switch that would change, or that would lock that down. But again, then it requires whatever switch infrastructure you have in your data center. You could, I don't know, like all this would be, so in the Acme protocol, for example, you don't have to use DNS. One way we could see in the future is that we figure out the perfect way to do this, and we could add another way to assert your identity, right? So maybe every BMC contains a public-private key that you can now get, and that could be like, we could add a new Acme challenge that says, yes, you're allowed to assert that because you have the secret for that. Like, we could certainly do that, but today my claim is that the network, like, if you have a bad actor on your local network, the way things are set up in a common data center, you're screwed anyway. So
yeah, okay, thank you.
Thanks. Any more questions? Or I think we're out of time. So.
Yep. Thanks for the talk.
Thanks.